All right, welcome to an afternoon video. So in the last video, we did a lot of, actually we didn't do that much in the last video. We just configured the first here, but we did kind of free ourselves from console configuration because that's typically not what you're going to have. I mean, you can have console servers, of course, but if you're going to do remote management, if you're in Atlanta and you want to configure Memphis, obviously you're not going to be able to walk over to the box and plug in. You're going to have a management network already set up and then go in and make configurations. So that's where we left off now. Last, we were working on our management network. So we can see these are all going to be IBGP connections. So we're going to need to set up our management network, and let's just keep it as simple as possible, and let's set up a management network. So we're not going to worry about ZTP, zero touch provisioning, right now. All we're going to worry about is a basic configuration that we can apply to every device in the network so that it's set up to have management. Okay, so now the thing is, we're going to have VLANs, because a VLAN is a virtual local area network, and we need to have multiple local area networks. We need to have one for this exercise here, but we need to have another one for our management network. But that is definitely not something that is difficult. So let's go on router A. So for management, we have the configuration we have on router A for setting up management is this set system services. We're also going to need a user account. And then I think that's everything. Oh, we need a special interface as well. But you can see that will not be necessary on those other routes, or those other routers. Okay, so in addition to that, we're also going to need another VLAN for our other traffic. So I'm going to use VLAN 196 or VLAN 192. 192 is kind of a number I really like because there's something called literal numbers, LICHREL, I think. I haven't really, IL, number 192. So these are palindromic numbers. So like a good example of a palindromic number is 11 or 131 or 1331. But there's kind of a theory. So a palindrome number is not necessarily, oh, well, I wish I knew what word that was. It's like a literal number or something. Maybe it'll be in the Wikipedia for palindromic number. It'll start with an L, LY, I believe. So it'll have a space and then LY. Aha, here we go, literal number. So a literal number is a natural number that cannot form a palindrome through the iterative process of repeatedly reversing its digits and adding the resulting numbers. So there's an open, unsolved problem in mathematics that we can see right here. Do any base 10 literal numbers exist. So is there any number in base 10, and I believe there are numbers in other bases, where you cannot form a palindrome through the iterative process of repeatedly reversing the digits and adding the resulting numbers. So, and this is a tangent, I hope to get back on track soon, but you can see 12 plus 21 equals 33, which is a palindromic number. So 12 is not a literal number, because you can achieve a palindromic number through an iterative process of reversing the digits and adding those reversed digits. And in fact, with 12, you can do it in one step. But let's see a number like 13. So 13 plus 31 equals 44. So same deal. But I think where it's going to get interesting is a number like 16, because 16 plus 61, or rather a number where you're adding, so 19 will be really interesting. So 19 plus 91 equals, 110. Yeah, because you'd get 101. Let's see here. So, yeah, which is not a palindromic number. Oh, yeah, because 90 plus 20 is definitely 110. Okay. So this is not a palindromic number, but it's, yeah, 110 is not a palindromic number. So you might think, oh, well, is 19 a literal number then? Well, it's an iterative process. So let's see if 0, 1, 1. So that's going to equal 11. So it's going to be 1, 2, 1. So we've got a palindromic number. So therefore we know that 19 is not a literal number, because it's an iterative process of adding the reverse. And the unsolved problem in mathematics is there such thing as a literal number where you can do this iterative process an infinite amount of times, but you'll never get a palindromic number as the sum. So it's something I found really interesting. When I was learning Python, it's something I used to gauge how fast Python runs, depending on whether you're using, because this is an iterative process, so there's many ways to do iterative processes in Python. So I kind of pit recursion against just a while loop, and saw just how much more efficient while loops were and how much better they were to use than recursion, and how much easier it was to think up. And through that process of learning Python, I discovered the number 192. And that's the first number where my Python program wasn't powerful enough to check all of the numbers. You've got to check billions, trillions of numbers to see. But checking numbers, that doesn't mean that it is a literal number, because it could be the very next number that you, the very next iteration could be the one where it results in a palindromic number. But the thing is, that next iteration, you're going to be adding two very, very large numbers. The deeper you go in, the bigger the numbers get. So there's a point where computation just breaks down. Like the biggest supercomputer in the world won't be able to tell you if infinity plus 1 is a palindromic number. So it'll even, I think, call out 192 in here. Oh, sorry, it's 196. See, I didn't even think it was 196 because 196 to me is like a really memorable number because it's, oh, sorry. 192 is the one that's in class C, private address space. 196 is the one that is not. Okay. But yeah, 196 is the smallest known number that is not known to form a palindrome. So this 196 could very well be a literal number. It's just we don't know yet if that is the case. But if it were the case, 196 would be the number we would be checking to see if that were the case. It would be the lowest possible number where it's reasonable to check if it's a literal number or not. So to me, that's a really interesting number. So I'm going to use that for the management VLAN, 196. Yeah, it's kind of a tangent. Sorry for that. I really need to be focusing on the test, but can't help but be interested by interesting things. All right. So device B. All right, and we're setting up the management network. So I've got to change the configuration on device A because I got to use 196 for my management VLAN. And I'll just do that by logging in. So edit, configure private. Edit int 009. Show pipe display, set relative. Okay, so now, oops, and I can't, it's not 9 that I'm gonna edit. And this is good because I'll be cutting off my legs a few times by accident, and that's something that'll definitely be applicable to real world production network engineering. So, okay. So, all right, so I'm gonna delete this. I think I'm gonna kind of stray from what is given in the documentation, and you can see I have to stray from it anyway because you can't use Unit 1 without proper encapsulation. So I think I'm more than justified in doing that. I'll keep the same description, but I'll put it under the physical interface, and then I'm going to set it to allow for VLAN tagging, and then I'm going to edit Unit 1 the way they want me to in the example. And now I'll set family inet address. But now I'm going to, and I gotta set the VLAN tag. Oops. VLAN tags. VLAN ID, sorry. 1. Okay, perfect. So up. There we go. So we got VLAN tagging, VLAN 1. So now let's do VLAN 196 for that literal number so that we got management. .16, and now we're going to need to choose a different network. We're already using .0 for the connection between the Linux server and router A, so the connection between router A and router B. Let's go with that one. Perfect. So now we've got getting rid of that .0. We're going to use .1 as they say in the doc, but we're going to correct them and assign a VLAN ID to it. Then we're going to set up a management network for 96. Commit. Okay, so now we're going to configure router B with that same sort of setup config. Unfortunately, we won't be able to get into that yet. So I'll need to do console on router B, unfortunately. Okay, so same deal as for router A. Got to pick a new network, but this time to connect router B and router C. And it looks like I set the host name to this to router C. I wonder what I set the host name to on router C. But it's definitely going to be B because it's the one I clicked on. But okay, so new network for this one. I'm going to go with family inet address 172.16.2.1/30. Okay, and then I'm going to fix that host name. Oops, and I'll put a IP address, or sorry, a description on GE001. And I'm not sure if I put this in there yet, so there's no harm in putting it in a second time. So I'll just put it in. Commit and quit. Oh, and I forgot to specify the VLAN tag. The VLAN ID. All right, so everything looks good. It looks like there's extra, oh yeah, there's extra on 000 and not 001 because I forgot a really important command on 001 VLAN tagging. I'm surprised it even, well, it'll let you put things in, it just won't let you commit them. So, oops, okay, perfect. And we're creating our SSH keys. Looks like we're creating a bunch of different keys that I kind of only want the RSA, but we got them all, so it doesn't matter. So yeah, so everything looks good. We are going to need another step eventually, but I'll save that for later and move on to router C. All right. Oh, and I forgot to apply SSH, so we won't see those keys forming until I apply that and commit. So now those keys are there. Everything looks good. But based on what we've seen so far, I have a question to pose. And that question is, am I all good to go? Or am I going to need another step in order to enable remote management from this management server? So think about the answers, 3, 2, 1. So the answer is that I'm going to need another step, and I'll show you why. So obviously I can ping myself. Oops. Oh, IF config. You can see, yeah, I'm used to using Windows. It's just, you know, back in college after high school, I met somebody who'd used Linux, you know, since they were 10, and it's like, you know, some people seem like they're geniuses, but a lot of them have just had extra opportunity. So kind of one thing I'd like people to know on this channel is that, like, you can learn. I definitely believe in the growth mindset. I believe that it's more important that you have the ability to learn something over time and get good at something than you're good at something right now. Because yeah, it's going to be important to be good at things right now. That's going to be essential in a lot of different areas. But whether or not you are good at something right now depends on what you have done in the past. And if your decisions on what you do are dependent on things that are not, it's just dependent on whatever you have the access or the opportunity to partake in. That's, I don't think, going to be as advantageous as if you do something like for me, like, you know, I don't have, you know, I went out and bought this $600 server, and I can stand up VMs, and I can learn and stuff. Like, that's the kind of thing I think is really important, is to kind of take those steps with learning, invest in your education. Of course, you know, do so wisely. Don't just throw money at education thinking that's how you learn. It's just about getting access. It's not like you just pay for education and you learn that way. You've got to actually go through the process of receiving education. But that's kind of something I have learned, is that I didn't necessarily believe when I was younger that education is something that it's a process, it's an activity you do and can become better at over time, and it's not something that you're either born with or you are given to. It's not that you have any intrinsic quality that makes you better or worse at something. It's that I mean, it could be obviously, if you have some sort of like physical disability, yeah, you're not going to be a marathon runner, but anything that I think, for the most part, anything you have the capacity to partake in, you will get better. Like, I think just I would say Google growth mindset and look up that, and that's really what I believe now. And I didn't necessarily believe that when I was younger. But here you can see destination host unreachable. So we were able to ping across the wire. We were but we weren't able to ping to 116, the 172.16.1.1 network. So that's because this management server, once it gets to router A, and it goes here, it doesn't, I'm actually surprised it wasn't able to ping 172.16.1.1 because I'm actually really surprised by that. So SSH to 16.0.1. Oops, and that's myself, so I got to go to that too. Oops, no, I am that one. Oh, but I'm using, so what happens when you don't specify a hostname like this is it just uses the hostname you already got. So I was trying to log in as root, but I got to log in as management in order to use that password. Actually, I'm surprised that didn't work because I have, oh, but my root account is not enabled for SSH. All right, so if I do a show route, you can see I've only got, oh, I do have OSPF enabled now, but I don't have any connections. It's only set up on router A. But I've got only directly connected routes. And you can see which route I'm missing here. I'm missing route .2. I've only got .0 and .1, which is kind of why I was confused why I wouldn't be able to ping 172.16.0.2 because I would think it'd be able to ping that since it's a directly connected route. It could ping from one to the other. But you can see very clearly it's not able to ping that, even though it is a directly connected route. So I'm actually really surprised by. I'm going to do a little bit of investigation in that because it's clear that by the level of my surprise, and I am like considerably surprised that that did not work, that I have some sort of misunderstanding. So why can't I ping from a direct route to another direct route? Here we go. So why can't I ping the next hop router? So let's see here. Hopefully this will help. So yeah, this looks right. No, this is the classic. Because let me pull up Paint. So I understand, of course, I would have had to pass the CCNA and get out of networking school and stuff. So let's say you have a topology like this, which is, it looks like that's what they were referring to. So, and then let's just call this network A, network B, and network C. So in the routing table here, you're going to have the directly connected routes A and B, but you're not going to have the route C unless you set up a routing protocol, or you can just create a static route and say, how do you get to C? You go through B. Same thing here. You're going to have B and C, and then if you wanted to go to A, how do you get to A? You go through B. You've got to set up those static routes. Now, the reason I am so confused, though, is because it appears that we've got a situation where we have a node here, but I cannot ping from here to here, which is something I really wasn't expecting. Like, I thought you would be able to do that, but it seems very clearly like I can't do that. I wonder if I can even ping. I wonder if I can ping from here to here. So I'll try that. So ping 172.16.1.1 and then source 0.1. Or actually so that's the local, yeah, 0.1. 172.16.0.1. Yeah, so I can do that. So what about, oh, and I'm gonna flip these actually because I want to ping from here to here, which you can see is very, it is this situation. So that's why I'm so surprised it's not working. Okay, so I can ping from here to here, but could I ping from here to here? And I know I couldn't ping from here to here because this route C would not be in there. And sure enough, I can't ping from, what? I wonder if I can ping 16.1.2. Yeah, I can. So that's really interesting. I don't know why I can't ping there just across the wire like that. That's really surprising to me. So I either don't have a proper understanding of how this works, or there's just some really weird thing going on with the virtualization. I wish I could see the subnet mask. It's not showing me that right now. Or sorry, not the subnet mask, the default gateway. But yeah, I can see destination default to that. So I don't know why it's not working. Let's try pinging it from this side. So destination host unreachable is what I get. Which again is really, really surprising. And I can show kind of more about what I was expecting. So if we go ahead and do this same idea, but instead of doing it so that I'm doing it from this address here over to that address, and we saw that a ping from this address here worked to this address, but from here did not work to that. So let's flip it around and let's see what happens a ping from this address to this address. So it's going to be ping 172.16.1.2 source 172.16.0.2. So it looks like, oh, okay. So .1 is what's configured on mine. So let's do a show inters. So yeah, I've got .1 on both of them. So I want to ping .2, and I'm going to use the source of .1, and it looks like we've got that same issue. And then, of course, if I ping my own interface, I can do that. But it's unable to ping across. So let's just think a little bit more carefully about this. So let's think more about what is happening, and let's think about where the decisions are going to be made. So, oh, okay, yeah, I understand now. So what's going on is, yes, in here you've got A, B, and here you've got B, C. So of course, if you're pinging from here to here, of course it's going to work because A and B are connected, right? But if you're pinging from here, when it gets here, it's got to get sent back somehow from this router here. But you can see all it's got is B and C. It has no idea that A is there. So even though it's the same network as this one, now you're going to look in this routing table, and it's got to go back to this network here, which isn't a part of that routing table. So my confusion was just that, oh, we weren't dealing with, you know, a third network. We were only dealing with two networks. So how in the world is it that you need a routing protocol just to route from one network to the other? Well, if you're just on one device and you're just using one routing table, you don't. We saw that. Yeah, you can just route from one network to the other. They're both directly connected routes, and they're both directly connected to this router. So yeah, you can route between them too. But once you go over to another device, now you're dealing with a different routing table, and that's going to have different routing information, and the directly connected routes on that table are just B and C. So when it tries to respond, it's missing A and no route to host. That's the classic response you'll get if there's an issue with what is in the routing table. So yeah, this was a really good learning exercise. I'm really glad it didn't stump me for too long. It's just, you know, things get rusty if you don't deal with them often. But if anyone out there hasn't, if this helped anyone, let me know in the comments. So let's see here. And if anyone needs a better explanation too, let me know in the comments. I can do start the next video with a better explanation of that. Although I think that should be good. I mean, I can just make it more concise or whatever. This is kind of in the middle of a long ranting video. So, okay, so moving on, now that that source of confusion is cleared up, yeah, so we saw exactly what we're going to need. We're going to need routes in the routing table that are relevant to, that allow everything to go through. So let's think about what we're going to need in the routing table of routing A. Well, we've already got these two routes, so we're only going to need this one here. So let's add that, and let's just add it as a static route, just for simplicity's sake. So set routing options protocol. Oh, routing options static route. And now the destination is going to be 172.16.2.0/30. And then next hop. Oops, next port. How about next hop? 172.16.1.2. There we go. So, and then we're going to need to do that for every router, and we're going to need to do that before we can get management from the term server for all of them. But one thing we can do now, so you can see I can ping the address on router A, but the address on router B still no luck. But you got to remember, so it's using my source address. And once it gets to router B, we didn't add that static route yet, so it doesn't have a route for that yet, based on using my source address. So how can we send a packet with a source address that router B can use? Well, there are many ways, especially if you throw SCAPI into the mix, which I think we might actually have on here, but that's definitely getting far off the, I don't even have it. That's getting far off the rails of what's going to be on this test. So definitely leave that for a different video series, which I'm hoping to do more of after this test. I mean, if I don't pass it on the first try, I'll probably just spend a few months studying for a retake. But if I fail it on the second try, I think I'll unfortunately have to move on. But let's see here. So everything, yeah. So how do I send a packet to router B with a source address that router B can use? Well, as I mentioned, there's ways you can do this, but the easiest way, just log on to router A, and now I have a source address that is meaningful to router B because I'm sourcing from router A. So I can just do 172.16.2.2. Oops, and it looks like it's going quite slow. I'm not sure what the delay is all about. Let me do a show in terse just to make extra sure I'm using the right. Oh, okay, yeah, it's going to be 1.1. So what happens is it doesn't have the well, actually, I'm surprised because, well, it's probably using the, as we saw in the documentation, the selection criteria for which source address to use, and it probably picked the source address in the other subnet, unfortunately. So, and that's something I'd like to read out loud again, just because of how valuable that is and how well written it is too. I think Juniper kind of hit it out of the water with this paragraph right here. When a device peers with a remote device's loopback interface address, the local device expects BGP update messages to come from, be sourced by the remote device's loopback interface address. The local address statement enables you to specify the source information in BGP update messages. If you would omit the local address statement, the expected source of BGP update messages is based on the router's source address selection rules. So this is good, which normally results in the egress interface address being the expected source of update messages. So, but in this case, we can see the source address was very likely not that. We can also try to ping this route. Oh, actually, never mind. So this is that source of confusion I had again, where the reason it's not working is because when it gets to router, so if we look at router A, and what we're trying to do right now is SSH into, oh, we're trying to SSH into router B actually. So I just used the wrong address. My bad. It's really not that complicated. Oops. Oh, and you can't use this syntax. So it's like -L or user. Let's see here. So what's it going to be? SSH. U host. So 172.116.1.2. And then maybe like username or something. I guess I don't see how to, oh, because I'm looking at the ping. It says my battery is low for my microphone here that I'm wearing. Oh, and it looks like I SSH'd into myself. Just trying to figure out how I can use a different host name when I SSH. But for some reason, that is more difficult than I had thought. Oh, okay. So it is that syntax. It's just I was using the wrong command. I was using ping instead of SSH. So let's go to .2. Perfect. Okay. So now hopefully this is, my battery's still low, even though I have it plugged in. I guess having it plugged in, and that helps with the battery no longer being low. So I'm going to switch over to speakers and headphones, or sorry, just I'm going to try to switch to yeah, there. I'm going to switch the microphone. So hopefully this works. I've got a different setup now. I'm now the Realtek audio. So that's, I think, the built-in speakers. So, okay. And the battery low, I mean, I'll plug it in so hopefully that charges it. But in any case, I'm on router B now. So let's go ahead and the first thing I'll do is get management nice and easy so that we can log in from the management server. We don't have to daisy chain hop to use the proper source address each time. Oops, and it looks like, aha, because I already have a session open to it through console, so it'll show me I've already got one open. So if I double click on B through the console, you can see I left myself in configure private mode. Yep. So if I exit out of configure private mode, and then I exit out here, go back in. I will no longer have that warning because I'm the only person in configure private mode. And it's fine for multiple people to be in configure private mode, but you can kind of be stepping on each other's toes. So if there's more than one person in. Like one thing I really like to do back when I was more on the commands line, is just to show system users as like one of the first commands I do. And then I can just see whoever's on there. And then you can even message the mask ER if you're on a particular kind of device. But unfortunately, that's hard to do on Junipers. But you can see I've got 3 users in, which is kind of interesting. But here's myself. So yeah, that's good. Another really good command, show system connections, because then you can see if anyone is downloading a file to the device using FTP, TFTP. So I can do pipe match 22 to look at all of the SSH connections, which we can see there are no SSH connections, because, I mean, that's weird because there is one. Oh, okay, it's not a colon, it's a dot. In Linux, it's a colon. So now I can see all the SSH connections. You can see I've got one here from myself and established. And then you can, one thing that's interesting that we'll see is the BGP connections as well showing up here. But perhaps the most useful way to use this is if you're doing a OS upgrade on the device and you download the OS to it, and I closed my terminal, is the download still going? You can do show system connections for the port that was used for your download, which is going to be 2021 if it's initiated from the other side. Unfortunately, if it's initiated from the Juniper, it's going to be an ephemeral port and it's going to be more difficult, but it will show up. Actually, it will be just as easy to filter out because it will show up on this side instead, because you can see in the show system connections command, you got your local address and your foreign address. So even if it's opened from your side, you'll just have an ephemeral in the local and then it'll show up in the foreign. So it's a really great way to see, oh, is my file transfer done yet? It's, I think, a very invaluable command and one that I used to use just about every week, just about every day for a while. I'd say when I was doing a lot of upgrades. But that was a long time ago. Okay. So, yeah, let's keep on moving with it. Well, actually, before we keep on moving with the exercise, let's finish setting up this management network. So we're going to need another stack route. So it's going to be the route connecting the management server to router A. So it's going to be 172.16.0.0/30. Then the next hop is, of course, going to be to router A. So it'll be next hop 172.16.0.1.1/30. Perfect. And so this is one thing that's kind of a good branch too, is, you know, you might think, oh, why don't I need a subnet mask here? Like, when do I need a subnet mask and when do I not need a subnet mask? So you need a subnet mask if you're going to be routing, if you're at layer 3. That's because it needs to know which subnet you're routing it to. In order to do that, if you're using FLSM, if you've got variable length subnet masking in use, it can't just assume that it's class A, class A, B, or class C. It's got to know that subnet mask to know what network to send it to. But if you're dealing with something that's on the same network that it's at, well, you don't need to know the subnet mask for it, because
what other route is it going to use? It uses the longest match in the table. So the longest match for 172.16.1.1 is going to be this /30 here. So it already knows what the subnet mask for that is. It's a /30 because it's got it in its table. So there's no need for it to constantly ask you what the subnet mask is for something where it already knows. And then what if you entered in the wrong subnet mask? Are they going to build a, an extra functionality to error check you on information that they already have? So that's I think a decent explanation about why you can expect certain commands to require the subnet mask and other commands not to. All right, so moving on to router B. Oh, sorry, router C. So we just finished router B. So now we're going to be moving on to router C. And on router C, we're going to need to add 2 different networks into as a static route. We're going to need to tell it how to get here. Well, actually, we might still just need, yeah, we're just going to need this one on router C. So, yeah, router A, we'll just need, well, actually, we might need 2. Yeah, I think we're going to need 2. Yeah, of course we're going to need 2 because this is where I'm not thinking properly. I'm not thinking about what the routing table is going to look like on this device. So is the routing table on this device going to have this network in it? No, it's not, because how would it show up? Is it directly connected to it? No. Is there a routing protocol set up? No, there's nothing set up on this router yet. So how is it going to know about that network? Well, we're going to tell it about that network. We're going to do it by statically entering it in and saying where it needs to go in order to reach it. All right, so, and then it's going to need every other network too. So it's going to need the .0 network, but fortunately it can use the same next hop. It's another big difference between Juniper and Cisco. Juniper, you can put anything you want for the next hop. Cisco, you have to put something that's an actual next hop. And you can have failover next hops in Juniper as well. Juniper, in general, I've found has had just kind of more functions and features than Cisco, but I think Junipers are a little bit more difficult conceptually sometimes, even though the CLI is so nice, just because you do have all those extra features. It's kind of harder to get a grasp on what you're doing sometimes, especially if you're learning it for the first time. Okay, so now let's do a history pipe ping and look at all the pings that we did. And let's go back and do them. So 1, and hopefully they'll all be good now. That, oops, So that's interesting. I don't have the traceroute command on here. I'm going to need that command. Let's see here, Linux. Oh, it doesn't have it by default, but you can install it. I don't think, yeah, I don't have the ability to ping the outside internet on this. It's something you can set up, of course, but I don't want to, I'd rather, like, I'm really surprised there's not traceroute on here. So let's see here. Yeah. Was there a tracer? Oh, that's on Windows. Yeah, it's a utility that you've got to install. It's not included by default, apparently. So that's too bad. And I don't have the ability to do sudo apt-get install because it's not hooked up to the internet. I could do that, but I'd rather not. I'm just confused why. Well, let's do this. Let's go back into every router and let's see what those routing tables look like, because that's going to be the best clue as to how this will work. Okay, so show route. So, and let's even do a show route static. Oops. Show route protocol static. So here we've got that looks good. So let's go on to the next one and let's do a show reverse quick. Yep, so this looks good via 1.2. So let's go to the next router. Okay, so it looks like, let's see here. So, B, yeah, so it has 1 to A, so yeah, B looks good. Yeah, let's take a look at C then. Yeah, and then we're using the correct next hop for that. Definitely something important to check. So let's see here. Show route protocol static. So now we've got 2 in there through this same subnet. Let's try some pings. So I think what the issue is going to be is with the routing table on the Linux server. I thought there was a default route. Yeah, I thought there was a default route, but there seems to be an issue with that. Because if I ping this route, I get destination host unreachable. And unfortunately, I don't have a trace route. I can yeah, I don't have any kind of trace route. I'm really surprised by that. Okay, so here's all the stuff I have. So if I do a quick grep ping, you can see, oh, this is just bash. So yeah, ping is a utility. But one thing I can do is find -name ping. I can see where it lives. Of course, I've got to search from a hierarchy. And now I can see where this lives. So it looks like bin.ping or bin/ping. So I'm going to go into this bin. And here we've got ping. So now I can see if I've got trace route, if I've got anything like that. So now let's type grep ping. So yep, I've got ping. I've also got the ability to ping IPv6. But let's see what I've got for TR. So yeah, it looks like I don't have anything. So unfortunately, by default, you don't get traceroute in Linux. You've got to, or at least in this distribution of Linux, you've got to go ahead and install it, which really sucks. Yeah, especially for a machine that is set up for automation. You'd think you would have something like traceroute automatically installed in it, but I guess not. No such file or directory. Okay, so here might have something a little bit better. Okay, well, I'm actually going to need to cut it short. I gotta take a quick break, but thanks for watching. See you in the next video. Hopefully I'll have this figured out.